Hey everyone, in this video we're going to be taking a look at the principle of inclusion and exclusion. This is a counting principle and we're going to focus on two sets. Just note that inclusion and exclusion applies to any number of sets. We're going to focus on two here just so we can get the basics down. So first of all, the principle itself is stated like this. You need first two sets, so let A and B sets. That's a terrible B. Any two sets. Then the principle of inclusion-exclusion is this equation, which tells us that the cardinality of the union of the two sets, so this means the number of elements that's in either one of those sets or both, and it gives us a nice formula for it, which is cardinality of A, that's the number of elements in A, plus the cardinality of B, minus the cardinality of the intersection. And so notice these are different. This is the union, this is the intersection. That's the elements that are in both of the sets. So this is it. That's the principle of inclusion-exclusion for two sets. It gives us a formula to find the cardinality of the union. And in this video I'm just going to show you two examples of how to use this. So let's say that you're in a class, and in this class there are only two types of majors. You have music majors and acting majors, and some double majors. So class, you have music majors, you have acting majors, and you have some double majors. But you have no other majors represented. And so you know a little bit about the makeup of the majors of the people in the class. So here's what you know. You know that there are 24 music majors. And you know that there are 15 acting majors. And you know 7 people are double. And notice I'm not saying music only and acting only. These are just people that say that they are music majors. But just by saying that you're a music major doesn't mean you're not an acting major. And 7 are double majors. So our question is, how many students are in the class? You know how many of each major, you know how many are double majors, how many students total. And so for these we can make sets, like M can be the set of all music majors, A can be the set of all acting majors, so then double majors, that would be M and A, the intersection. And how many total students? Well, total, there are only two types of majors, so that would be the union. What's the cardinality of the union? That's how we rephrase our question in set theory. So our formula says the total number of students in the union, or total number of students in the class, is equal to the number of music majors plus the number of acting majors minus the number of double majors. And we just plug things in as we see what we know. 24, 15, 7, compute this, you get 32. So that's our answer. 32 students total in the class. As another example, we're going to use this opportunity to settle an age-old dispute. And we're going to say that we conduct a poll of 100 gamers. And we ask them about 2 games, and we ask if they play them. And the question is, how many play the game Fortnite, and how many play PUBG? And then of course how many play both. And note that all 100 play at least one of these 2 games. So everybody that we ask plays at least one of the games. Some of them play 2 of the games. And here are the results. The people that play Fortnite, there were 54 of them. And the people that play PUBG, let's call that set P, there were 62 of them. And our question is, how many play both? We didn't actually ask them that, but we know how many total people there are. That's 100. So here's another thing that we know. Since we controlled the experiment, we know that the Fortnite players and the PUBG players total 100 total people that we asked. And so if we use our formula, inclusion, exclusion, the cardinality of the union is the cardinality of the number of Fortnite players, the set of Fortnite players, plus the cardinality of the set of PUBG players, minus the cardinality of the intersection. And these are the people that play both. So that's what we want to solve for. So we just plug these things in. We have on the left 100, here's 54, here's 62, and then this, even though it doesn't look like it, that's our variable. That's what we want to solve for. And notice right now it's negative, so I want to flip this over to the other side. But since I took this intersection to the other side, I want to get rid of this 100, so I'm going to subtract that to the right hand side. So I have 54 plus 62 still here, and then that minus 100. So these just kind of switched. And so then you just do some computations and it looks like you end up with 16. So there's 16 players that play both. Note, this is a made-up survey. Thanks.